Because this is really getting in, guys, to word problem type thing. So we're going to take this slow and we're going to talk about how we interpret words into mathematical expressions. Tell me again what an expression is.
The word.
What's an algebraic expression?
It has an equal. No, that's the one without the equal.
Without an equal sign. So I've got numbers, operations, and variables in an algebraic expression. In just an expression, it doesn't have to have variables, but I've got operations, okay? Everything we did this morning in warm-ups are expressions, okay? And you brought up a good point. Expressions do not have equal signs. Equations have equal signs. Expressions do not, okay? Equations have equal signs. Expressions do not, okay? So, yeah, they're both. Equation is EQUA and equal is EQUA. You know? Equation, equal sign. Yeah? Okay. So let's talk about some ways we describe things when they're in a word problem, or some ways we can say it in words. If I'm talking about addition, tell me some ways we describe addition in words. Add, sum, more than, yes, more is good, more than. What else?
What are we doing?
You know what we're doing? We're going to try to take... We're going to give some common terms, right, and we're going to interpret as expressions.
Yeah,
that's exactly right.
Like that.
How about total? I'm going to hold off on greater than because when we get to inequalities, I don't want it to start getting all discombobulated in your head. Increased by? Okay. Any of these words in in a problem would indicate to me I need to add. How about subtraction?
No. Let's say no.
Somebody said take away.
Oh.
What else? How about minus? 5 minus 2. What else? Starts with a D. There's a big one that starts. D-I. Difference.
I would have never done it.
The difference of two numbers means to subtract. What else? If addition is increased by, what could we use for subtraction? Decreased by.
I said that too. Oh, that's right.
How about multiplication? Y'all need a second to copy this before I go to the next one?
Yes.
Okay.
Yes.
See what happens, and then we'll add the multiplication division after I do a couple examples. Let's say I told you to write an expression for a number y, yeah, minus 3. How would you write that as an expression?
Like a number?
Y minus 3. Yes, a number y. Like any number y, I'm saying I'm going to use a variable. Okay.
Why would you do add one?
This is in words. This is as an expression.
This is what I don't like. Let's just put y plus.
Oh, I'm sorry. I'm changing it. Guys, I need y'all to focus. Okay? How about...
Can you stop? Can you leave him alone? He was doing his thing.
How about, guys? A number x plus 5. There it is in words. How would you write an expression that represents that?
X plus sign.
X plus 5. I'm going to throw you a little curveball here, okay? So pay attention. What if I said 7 less than a number, if I can write, a number K? 7 less than a number K.
7 minus 3K.
What?
She said a number K. No, this is
7 minus K. She said 3K.
All right, let me ask you this.
What is X?
Let me tell you this a different way. I have $7 less than you.
Oh, so you.
It's a track.
K minus. So.
K minus
You
5.
gotta figure out what
You got to do it around. You got to twist it around whenever you're talking about. Yeah. So what is it? K minus 7. I'm sorry, I couldn't. I'm sorry.
Okay, what is 7 come from?
Look at the problem.
7. Oh my gosh.
Okay. When you see those words less than, it can be a little confusing. Okay. A lot of times I tell students, if you think about it in terms of money, it'll make more sense to you. Okay. If I have $7 less than K.
Confuses me more.
Yeah.
Using money?
Okay, what is K?
Like, I just.
Into multiplication and division. Tell me some words that describe multiplication. Times, that's everybody's favorite. Product, good job. What else? Multiply.
At this time.
One that you may not know. Many times the word of
Oh, yeah.
will mean to multiply. 1/3 of 6 would mean 1/3 times 6. So the word of can be used in place of multiplication also. Okay. How about division? Divide. What else? How about it starts with a Q? Good job. Quotient, maybe, and I just put divide, maybe it says divided by, divides, the division of, any form of that divide word. Let's do a couple examples with these two, and then we're going to put all 4 together into words and see what happens. Y'all ready? I'll give you a second to copy. What if I said 12 times a number P? P times 12, or 12P. Okay. Remember, we don't have to, when we have variables in there, we can just put them together and we know that that implies multiplication.
Wait, don't erase it yet.
I'm not. What if I said 1/5 of 25? That's multiplication. That is 1/5 times 25. That of means to multiply. Yeah. And I do want to show you one division. The quotient of y and 7. Y divided by 7. So remember, the only one that starts getting twisted a little bit is the subtraction one. With division, if you write quotient like that, it's exactly how it's written. So it's y divided by 7. Is everybody okay on a single operation so far before we turn them into multiples? Okay. A couple of things before we interpret. If you see something that says like in a word problem, the quantity.
That's right. The try six.
Well, this one in a word problem, it's a grouping thing. The quantity means that it groups. So in other words, if I said the quantity of x and 2 divided by 3, that would tell me the x and 2, I could put parentheses around, okay? When I say the quantity, it groups, so we need to think some parentheses. I want to make sure I tell you everything before we just jump into it. Okay. Let me give you an example. 4 less than the quantity six times n. All right, so now you got to be very careful here though, because remember about the less than. All right, first thing I'm going to do is I know that this quantity is going to mean that these two things are together, right? So times means what? Multiply. So I'm going to know that this is 6 times n. Now, 4 less than 6 times n.
4 minus
6 and minus 4?
6n minus 4. 4 is less than the 6n. 4, you see what I'm saying?
Yeah.
So it's 6n minus 4. That's 4 less than 6. Does that make sense? Let's do another one. Okay. I'm going to put them up here, and then I'm going to give you a second to look at them, and then we'll talk about them. I got you 3 up here that probably increase in difficulty as you go. Okay, and we're going to talk about them if you'll copy them down and try them, and then we're going to talk about them. You need to stop me, okay?
Yes, ma'am.
Don't sit there and not understand what I'm saying. All right, so let's talk about what some of these words mean, okay? Times, I know, means what? Multiply. Sum means add. All right, so 3 times the sum of 7 and y.
So what if it 3 times plus 7 plus y?
3 times 7 plus y. I need to put these in parentheses because it's talking about the sum of these two, which means before I multiply it by anything, I need to add them together. You could. It doesn't matter. That's fine.
Okay.
If you did 7 plus y times 3, that's fine. Yeah, that's fine. How about the second one? Difference we know means what? Subtract.
22 minus
What's the
x.
square of x mean?
X.
To the power of 2. All right, so the difference of, now this is not less than, so it's not backwards, okay? The difference of 22 and x squared.
Minus 22
Yes. Yes. All right, last one's hard. I see quantity. Well, quantity tells me to start with parentheses. So I know that this is in parentheses. Quotient means division, so this is going to be a division problem. Plus means add. There's divided again. Okay. You're exactly right. 10 plus k, there's my quantity of 10 plus k, divided by negative. Okay, is everybody okay on those?
Yes.
It's simple. I know everybody struggles with this. It takes practice to pick up what it has to look like as an expression, okay? All right, let's talk about some word problems and let's put this into play a little bit.
All tips will be split, all tips.
Must be split. Same difference, it don't matter. Okay, so look at the first one. Let's look at the first one together and let's think about it. And all I'm asking you to do is write an expression that represents it, okay? So a piece of ribbon is 8 feet long. A piece of ribbon X feet long is cut off of a piece of ribbon that's 8 feet long. So how long was the original?
8 feet.
8 feet. So I got this original one. This is 8, but I'm cutting off this piece that's X feet long, right? So how much ribbon's left? How do I write that as an expression? 8 minus X. You see, the problem didn't say write an expression for X less than 8, or the difference of 8 and X. You had to interpret that by reading the problem. Look at the second one. You work with 5 people. All tips must be split. Let's say that tips, let's say all tips are, we'll call them Y. That's how you make Y amount of tips. Y divided, well, close. You work with 5 people, so how many people are there altogether? 6. You got to count yourself, right? So take all the tips and divide them by 6. Yes? Okay. So this is just literally taking what's there and interpreting it to write an expression. Okay, on to the part I hate. Not hate, but just, unit conversion. I hope at some point that you have seen this before. All right, so here's what you have to remember with unit conversion. You can multiply anything by 1 and it stays the same, right? We all agree with that. Anything times itself, 1 times anything is what you started with. So 1 times 10 is 10. 5 over 6 times 10 is, times 1 is 5 over 6. It stays the same, right? 1 is that identity that I can multiply anything by. So with unit conversion, what you have to remember is we can have fractions that just because the units aren't the same in the top and the bottom, they're still 1. For instance, there are 24 hours in one day. So if I were to divide 24 hours by 1 day, I still get 1, right? They're the same, aren't they? Is 24 hours the same thing as 1 day? Yeah. Is it multiplying? I'm dividing here. I'm making fractions. I'm making fractions that equal 1. I'm just showing you before I start. Help me think of some more. How about 1 foot 12 inches? That's still 1. Think of some more. What are some more? How about
365 days in 1 year.
Good job. 365 days.
In 12 months.
1 year. What? Or, yes. Oh, yeah. 365 days, 12 months. How about,
I would do like 7 days.
and you can flip these. They can be the other way around. Okay. How about,
Oh, yes, 7 days in a week.
60.
yes, 60 minutes, 1 hour. Let's see, some common ones you're probably going to use. Oh, you'll use the minutes and the hours. How about, I'm sorry, I didn't mean to go that far. How about 5,280 feet?
1 mile.
Yes. How about, and you can flip these, remember. How about 60 seconds
1 minute.
in 1 minute? Okay. The point I'm getting, there are an infinite number of these. but they all equal 1. Okay, and the reason this is handy is we can convert something from, say, miles per hour to feet per second using these. Okay, and here's how we're going to do it. If you see a fraction that has miles hour, I'm going to make this a big fraction here.
No.
Now there would be numbers in here too, but I just want you to see. Actually, make those seconds minutes.
What?
Oh my God.
Sorry. Let's say I've got this big fraction and I've got some numbers. There's some numbers here in front of this. Whenever I multiply fractions, I'm top times top and bottom times bottom. When you have units in your fraction like this, if they're in the top and the bottom, they cancel out. Okay? So here, I can cancel out the minutes. This is supposed to be seconds. God, jeez. The hours. And so what I would have at the end, I would have an answer in miles per second rather than miles per hour. Okay? So we're going to go through an example where we're going to convert from miles per hour to feet per second. Okay?
Oh, I get it.
So watch what happens. If a car drives, and I'm going to use this example they have so it comes out nice, 120 miles in 2 hours, how many feet per second was it going?
Oh.
Per means divide, by the way.
Okay.
I should have, I'm sorry. I didn't look far enough ahead and realize we were doing a conversion today. All right, so 120 miles in 2 hours is 120 miles per 2 hours, right? All right, so we're going to start with 120 miles, how many feet per second, over 2 hours. Now, I need to get the top, I need to get the miles to go away, right? What do I want it to be instead?
Feet.
Feet. So I need to multiply by a fraction that's 1. On the bottom, I need it to be miles because that's what I want to cancel out. So what kind of fraction can I make with miles that's still equal to 1? We did it a minute ago.
5,000.
5,280 feet. That might be one you just need to write down somewhere so you know. Okay. If I multiplied this as is, I would be in feet per hours. But I need to be in what?
Feet per second.
Feet per second. So my top unit is good now. I need to get the bottom somehow to be seconds. Right now it's hours.
We got to do 60 seconds.
You're okay, so 60 minutes in an hour. What needs to go up top? The hours or the minutes? Look at what you need to keep. The hours. Why?
Because hours is already on the.
I need hours to go away. Right? This allows me to take the hours away. Now what are my units? Feet per minute, but what do I need it in?
You got it.
Feet per second.
You got to write it in 60.
60 seconds in 1 minute. Which one needs to go on top, the minute or the seconds? The minute. Why the minute on top? It's on the bottom. They have to be 7. There's 60 seconds. Now the minutes are gone. All right, look. We're just working to try to cancel them out, but we can only multiply by things that equal
This
1.
page is so full.
Okay, look across the top. What units left? Across the top. Feet. And across the bottom? Seconds. So now, all I have to do is multiply. Watch what happens. 120. Remember, top times top, bottom times bottom, right? Times 5,280 feet over 2 times 1 doesn't really count right, that stays the same. 60 times 60 seconds. Okay? The key is you have to be multiplying. Now we're going to simplify this
You're
down.
just trying to cancel out like minutes, seconds,
We're
hours.
trying,
You're not
yes.
canceling out the
You're not,
numbers.
well, we will. We'll simplify this fraction, but as you're coming up with what you want to do here, you're just working to cancel out the units.
Okay, yes. That makes sense now. Because I was like, what?
Let's see what we get here. What is it? 1280 times what? I'm in 5280.
5280 times.
$633,600. Feet. I just multiplied those two together, those two numbers. 120 times 5,280. 60 times 60 would be 360 times 2. What do you get?
That's 120.
Dude, what's 2 times 60 times 60?
Oh.
Somebody with a calculator plug it in for me.
Like I have my calculator. I was like, oh my GG.
Please don't start that back up.
200 even. Now what happens if you do 6,336,00 divided by 7,200? Yes, because it's a fraction. Let's see if it goes in evenly good. 88. This means that we have taken 120 miles in 2 hours and converted it to feet per second.
Okay.
I know. I know that this is something that is difficult.